Thanks very much for joining us today. My name is Phil Griston, and I'm from a company called Gigamon. We are actually a technical alliance partner of Palo Alto, but we're also a supplier to Palo Alto. And today I'm here as a customer of Palo Alto to talk about a solution that we've deployed in our network for our development guys. I'm going to spend about 10 minutes talking about what we've done, why we've done it, and then my colleague Dexter here is going to get into the technical depth of what we've done, how we've done it, what issues we hit, and hopefully give you a lot of useful information if you're thinking of doing something similar yourself. But to give you context of why we approached this project, Gigamon is a 14-year-old company, publicly quoted, about $300 million of revenue every year, 700 employees, and all we do is find ways to extract what we call data in motion, traffic flowing across our customers' networks, and efficiently delivering that traffic to tools that need to see the traffic and analyze that traffic. So hence a relationship with Palo Alto Networks. We provide a lot of customers with easy ways of deploying their next-gen firewalls. That's all we spend our time doing. And say it's obviously a big business for us, but 2 or 3 years ago, we had our customer base telling us that their environments were changing, and we needed to figure out how to continue to deliver the solutions that they required to them. So as you can see, very large companies use our solutions. They have very large networks, and they have a multitude of technologies. In the history of the company, we had built a very wide range of hardware platforms that tap into physical fiber or copper networks, extract the traffic from those networks, and manipulate it in certain ways, which I'm not going to go into, deliver it to the tools in the most efficient way that they can most effectively perform the functions that they wanted to perform. That was relatively easy. Developing those and enhancing that situation, having our developers work on the software that runs on the platform, it was all known business. We understood how to do it, we understood how to improve it, and we understood how to give our developers the best chance of being the most efficient in adding enhancements to the product. In terms of Palo Alto Networks, I think they talked about protecting the perimeter, and understanding the perimeter of the organization was easy. And we all know what's happened in the last few years. Public cloud has come along. Everybody is thinking, how do I take advantage of public cloud? How do I move some, all of my workloads into the public cloud to take advantage of that flexibility of the environment? And yet, I still need to be secure. I still need to manage what is going on. So our simple networks that were nicely contained with a nice perimeter changed. There were now lots of different technologies involved. We could have public cloud, we can have private cloud. Obviously, we have physical infrastructure, we have leased infrastructure that we're taking from service providers, we have remote sites. All of that we need to have complete visibility into. We need to be able to pull traffic from any of that. And there are applications that we don't know where they're sitting that are generating that traffic, sending information from any point to any point. We need to be able to intercept it and feed it into the tools that need to see that traffic. And of course, there's lots of different people generating that data in motion, whether it is applications, whether it's customers, whether it's partners. All of these things are adding complexity to the networks that we're building the infrastructure and adding infrastructure to enable our customers to see what's going on those networks. And of course, why do they want to see what's going on? Well, the bad guys are everywhere. And yes, you can certainly protect yourselves, but with this kind of lack of perimeter on a network, it's inevitable that some of the bad stuff is going to get onto the network. And the more that you can see of what's flowing across the network, the faster you can identify there's something wrong, and the faster you can stop it and isolate it. So our customers were demanding that we have a solution that expands to the technologies that they were looking at, and the most pressing technology that they were looking at was the public cloud. So we, of course, when we market ourselves, make the diagram look very simple because, hey, we've got it all under control. But this is really what we were building, and I'm going to... Apologies to those of you sitting right over there. If you can't see what I'm doing, I'll, I'll point it out. But we are committed to delivering our customers solutions that enable them to pull traffic from public cloud environments, from private virtual environments, and we have development relationships with VMware for NSX solutions, and we have ACI solutions, and obviously still being able to tap the on-premise physical infrastructure. All of that needed to feed into our platform, and we need to be able to deliver it to the tools and technologies that our customers wanted to use. Whether those tools sat on physical infrastructure or whether they sat in the cloud, whatever, we needed to be able to do that. So a little over 2 years ago, we sat down as a business and started our process of migration to the cloud. I'm sure you've seen lots of these kinds of presentations, both here and in Amazon's conferences and Microsoft's conferences. I'm going to talk a little bit about a process, 2 or 3 minutes, but I'm going to get down to the particular project of automating our development environments. So we looked at all of these things and decided as a business we needed to spend time thinking about how do we make sure that what we're taking to market, what we're giving to our customers is deliverable in the public cloud. The value proposition to the customer was exactly the same. We're giving them easy and efficient access to the traffic flowing across their network. The way that it got delivered was completely different and is completely different and has required a lot of changes within the company. You can see some of them listed out here. Obviously, people expect to be able to license software in a different way in the public cloud. It needs to be much more flexible, much more elastic, and the term commitments are much smaller. My job as managing the partner and alliances that Gigamon has, you can imagine we have over 100 different alliance partners that plug their tools into a Gigamon box to get traffic from or netflow data from the network. Moving into public cloud, there's a completely different ecosystem of companies that work. Certainly some of the traditional partners that we had, like Palo Alto, have solutions in public cloud, but there's also a whole new set of technologies and tools that have grown up in that space that we needed to be able to interface with. I won't bore you with the joys of sales compensation, but changing the way you sell and license software means that you have to incent your sales guys in a different way, and that's a big change for a vendor organization. And then we also saw that customers buy the product in a different way. So if we wanted to do an evaluation with our hardware devices, we could ship the box. We could tell people how to configure the system, plug it into the tools that they're interested in, and away they go. We had to think of a whole different mechanism for doing that within public cloud, of giving people easy access that we knew was mistake-free configuration for them to try out what we were trying to sell them. And we also realized, because of that fact that you don't want things to go wrong because they stop you delivering value to the customer, we wanted to automate as much as we possibly could in every aspect of the business as we moved into the cloud. So let's drill down into the development and QA strategy and the thought process we went through there. These were the sort of key guiding principles of what we needed to consider. And we went through and discussed each of these as a group as we developed our plans for developing our public cloud products. Where that left us was with the guiding principle that everything we do had to be secure, and it had to be secure for 2 purposes. One, as a company, our business is visibility for customers. We were putting a lot of our pre-existing IP into our public cloud offering. Absolutely, we were integrating it and making it work the best it possibly could within public cloud, but the core underlying technology of a lot of the functionality that we deliver is the same across our platform, whatever technology you're implementing it on. And so we had to protect that IP when we were putting it out there. But also, of course, everything that we build needs to be secure for the customer. They're going to be deploying it in their own environments, in their own VPCs, in AWS, and we wanted to make sure that everything was fully auditable and secure. We needed our engineers to be able to provision accounts. each of our developers had to be able to go set up their own environment to be able to start developing the code that we needed, testing functionality that we had, running QA and running scale testing. And you know what? Yes, we have some folks that are expert in AWS and some folks expert in Azure, but most of our really key developers are expert in the visibility technology that we develop. And so we wanted to make it easy for them to be able to set up their environments and easy for the company to be able to standardize those environments. We also needed to change our workflows. The normal workflow of a development organization, run through development, QA, test, puts it ready for shipping, puts it into manufacturing, gets sent through build and warehouse and out to the market. The AWS and the public cloud model is completely different. It gave us great opportunities to automate that process, but it was also something new that we needed to learn. And of course, performance and scale testing is very different. I'm sure you understand the need for elasticity, the need to be able to scale up and scale down what you're doing. And it's not just a matter of putting more machines out there and seeing if they operate correctly. A cloud deployment could almost be limitless in the size that you need to be able to test for. And again, I added to our development and QA thought process, how do we extend that to customer evaluation and sales and marketing? Because we were building these environments, the tools effectively just had a life within the public cloud themselves, and we needed a complete workflow to make it easy for customers to access, to test, to evaluate, and then to deploy the software. And so we just see it as a continuous process, and we're trying to automate the continuous process that we go through. What did we learn when we got to this stage? Well, one thing we learned is that you don't give developers freedom to set up their own AWS environments. It's not a good idea. Everybody does it differently. Everybody sets up things slightly differently. Everybody forgets what instances they've started running, leaves them running when they don't need to be running. We watched our invoices from Amazon go up and up and up. The Amazon sales guy was extremely happy, of course, for a short period of time. But it very quickly became apparent that that wasn't the way to do it. I also talked about, we have a lot of very smart developers in our organization, but a lot of them were not cloud savvy. We needed to give them help. We needed to make it as easy as possible for them to get set up in an environment that they could start effective work in. We didn't have the automation processes in place that we needed. Again, we were a hardware-focused company. Yes, we develop a lot of software that runs on that hardware, but it was our own environment. We knew how to manage it. We knew how to contain it. This was a completely different model for us. And IT was extremely uncomfortable with what we were doing because they had no insight into how many resources are being used. How many machines does each developer need to spin up? In the past, of course, if a developer needed a new machine, he'd have to go ask and procure it, and it would all go through an approval process. Doesn't happen in the cloud. They can just spin up machines as they want. So we needed something that gave us that control, that automation, and what we really needed was we needed some help. So we brought in some experts, and Dexter is going to talk to you about what we asked those experts to do.
Thanks, Phil. So my name is Dexter Markley, and I work with REAN Cloud. I am a cloud architect, and so I work with a lot of different companies to understand what their business needs are and to architect AWS solutions for them that are going to work not just for today, but try and future-proof and build robust solutions for them to ease migrations to the cloud or build new workloads in the cloud. And at REAN Cloud, we're cloud experts. We were born in the cloud, if you will. We started just kind of collecting all of these competencies, and this isn't even all of them. We really love working in AWS. It's our passion, and we are constantly trying to figure out new ways of innovating in AWS for our customers. So Gigamon came to us with this issue. Put yourself in the shoes of a Gigamon engineer. They used to, and still do, but before they moved on to the cloud team, they had a literal server room in the middle of their office, and it's actually really beautiful. It's this like glass encased thing, and you go in there, and people are moving crash carts around, trying stuff out, and they were enabled. They had what they needed to do their development and engineering. But when it came to AWS, they started, it was a little bit of a free-for-all at first. And so that's kind of the problem that you heard Phil outlining. But we were able to come in and help them understand how they can leverage the power of automation and DevOps mentalities to build a solution that enabled their engineers to build their environments in the cloud. So essentially, Gigamon's tool is a visibility system, so you get full packet capture from every instance that's running in a VPC. But that means that the engineers need a whole VPC to themselves to be able to test out and develop this solution. And Gigamon right now, to their credit, it's amazing. They're, as far as I know, the only aggregated full capture system in AWS, and I've worked with it a lot. It's a really cool tool. They actually have a test drive as well that you can go and check out on their website and just play with it. And it's a really cool system. If you're interested in security, it's one of the best systems out there for getting that full visibility. So I started working with their IT team, and I said, okay, well, we can start to limit AWS permissions by moving everyone into an automation pipeline, and we can also automate all of those workflows and make it really fast for their developers and engineers to get an environment to start working in. Literally faster than it would take for them to walk over into that little server room and plug in the system and get the crash cart going. They can just sit at their desk, hit, I want another one, and that system would spin up. And we can use the Palo Alto VM Series firewall to build VPNs so that they, from their workstations at their desk or when they VPN at home, they already have access right now to that new VPC that stood up. And we also wanted to make sure that they were secure. So the whole point in using the Palo Alto VM Series firewall was they're already using that, the IT department was already using that in their office location. They love the visibility that it gives on the traffic that's coming in and out of their environment. What they didn't like about how their engineers were using AWS before was they could have new connections going out to the internet all the time, and they couldn't make sure that they're keeping a secure environment for those development VPCs. So we could use Palo Alto and REAN Radar, which is an accelerator that my company has built for getting visibility on what is in AWS. And we'll talk a little bit more about that at the end if we have time. So here it is. This is what we went ahead and built for Gigamon. We have a control VPC where we installed the VM Series firewall in HA. So you can see we built it in one availability zone in this scenario. If we have time, we'll talk a little bit more about that towards the end. But over on the far-hand side, the left hand for you guys, we have development VPCs that are all connected already to the Palo Alto VM Series firewall. And we can see right here, we have their on-prem is connected. We have different development VPCs that are connected, and we even have different regions that are able to be connected to the system. So I will go ahead and walk through how we built this from start to finish. So the first thing that we needed to do is we needed to actually provision the control VPC. This is what's going to host the more static resources for the environment, something like REAN Radar or the Palo Alto VM Series firewall that will be accepting new VPN connections from these VPCs that we stand up, and also the connections back to the office so that everything's already meshed and ready to go. So we use a deployment tool like CloudFormation. In this scenario, we use REAN Deploy, which is another one of our accelerators, to provision the VPC, the subnets, internet gateway, the structure, if you will. A lot of times in AWS, we deploy in layers. And they're kind of based on what's going to change as the environment grows and gets modified. Most of the time, you make a good decision about how you're going to deploy your subnets and your VPCs and your routing tables, and those don't change much. So we want to deploy those first, and then we want to deploy new resources on top of that that are going to be more ephemeral, more changing more often. So here's a snapshot of our deployment system that we used. So a little bit of shameless self-promotion here. This is our deployment system that we use to drag and drop AWS resources to provision something like a VPC or Palo Alto firewalls. It accomplishes the same thing as something like CloudFormation or Terraform would do for you. But the great thing is, as you can see, it's a visual GUI system. So we can drag and drop resources in there, configure them however we want. Even better, we can share blueprints of an environment. So at REAN, we have worked really hard to build out a VPC deployment that we consider to be secure and best practice, and we reuse that over and over and over again with this system. So now we have our VPC, and this is where we start to get a little bit different than a normal deployment you would do in AWS. I wanted to be able to have a completely fully managed deployment, an automated system for getting my VM series firewalls up in any VPC configuration, even if it wasn't this. And that posed some significant problems, especially since I also wanted to bootstrap my VM series firewalls so that when they come up, they're already ready to go. And I can already start using them as soon as that instance says, hey, I'm good. So the challenge was, how do we know about the network interfaces before we've deployed the instances? Because I want to use the IP addresses of those instances in the configuration that I'm going to try and bootstrap with. Well, the solution that we came up with is let's deploy the networking infrastructure first, and then we can use an orchestrator like Jenkins to go and reap that information back out of what we just deployed. So I never told AWS, I want a static IP address, I want to use these over here. No, I just say, hey, deploy this, and then tell me what IP addresses you gave it. The benefits of that is I can go and I can deploy this again and again and again, even in the same VPC, and there's still room. I didn't collide with it because I didn't hard code anything. And that's about understanding the how to take automation all the way to the fullest extent, right? I can now reuse this system in the same VPC, in a new customer's VPC, if someone else wanted to use it. So it gives me lots of control. And there's another reason why this was important, and I'll tell you about that, hopefully, if we have time. But an important component is the orchestrator. We use Jenkins in this scenario. How many of you guys have used Jenkins before? OK, cool. So we have about half the room, seems like maybe has used it. Jenkins is great because you just build pipelines of code. I can go in, I can write a bash script and say, do this one thing, and then go do this next thing after that one's done. There's a lot of hesitancy sometimes for people to get into automation when they look at a tool like Jenkins. And just think of, if you already write IT code to do anything on a server at any point in time, you're ready to start using an orchestration tool like Jenkins. It will take you just a few minutes to start getting used to it. So it's worthwhile of doing. But we needed something to glue together the logic of building this system. And we also needed a place where Gigamon engineers and developers could go and say, I want a system. So we used Jenkins to do that. You could also use AWS Lambda or simple workflow in AWS if you wanted to. So our orchestrator runs some Python code that goes out and grabs all these interfaces and stores it as variables in its system. And then we wanted to use that as bootstrap code. One trick that we noticed was you can use just your running configuration in your Palo Alto as its bootstrap. So we built the system first just using clicks to go through and build a VPN, build some of our security policies that we wanted the system to have. And then we went ahead and just exported it out of the system. And that we downloaded this piece of XML data. And here's a snippet of what it looked like. But notice in this system, in this XML code, we have the hard-coded IP addresses that I was talking about. So I don't want to use those IP addresses because it's going to change every time I deploy the system. So what we did is after we reaped that code, we took this XML data and we replaced it with ERB code, which is a templating Ruby system that you can use to replace values inside of just a regular template file. So if we back up and look at what we had here, this value that we have set for that ENI ends up getting injected into this XML code. And now every time we deploy the system, we deploy the networking, grab information from the networking, fill out this template with those variables that we got, and then we push it into our configuration S3 buckets. These S3 buckets are just like a USB stick that you would use in your data center for bootstrapping a Palo Alto device. When you tell the Palo Alto instances that they had just the name of the S3 bucket in the user data section in AWS. And the really cool bootstrapping system that Palo Alto Networks have built for the VM series firewall will just go out to that S3 bucket and look for some specific data in the S3 bucket. So we have our config, content, license, and software. One trick that we noticed is regardless of whether you put things in all of these S3 buckets or S3 folders, you need to have them all there so that the code knows, hey, this really is a bootstrap S3 bucket. I can go ahead and use it. So we went ahead and dropped using automation, dropped the bootstrap XML into the configuration folder. And so this has the IP addresses that got used for this specific deployment inside of it. And now our VM series firewalls are ready to come up. So we go back to our deployment engine, and we say, provision our instances. So now these two instances come up. They read from the bootstrap config buckets, and that tells them a certain set of tasks that they need to do. I want to get HA started. I want to build a VPN back to the office. And I want to apply these certain sets of rules for security reasons. So they come up, they read the bootstrap XML, and now, bam, we're connected to the on-prem network for this first deployment. At this point, the office in Gigamon in Santa Clara is already ready to go ahead and talk to resources in the control VPC. So the VPN is established. Now we had to go ahead and use the XML API to establish HA between these two instances. You cannot do HA initiation just using a bootstrap XML. You have to do that as a post-bootstrap task. How many people here have used the XML API before? Awesome. That's really great. It's a really awesome way of getting your configuration set up. One trick for you guys, for those of you who haven't used it before, you can apply your configuration using the GUI and then export your code again and look at the XML code that is now in the configuration. That's going to be very similar to the API call that you need to make. And so sometimes if you're having a little bit of trouble understanding how do I make this API call, go look at the exported code. It will get you a little bit further down the path and help you do some troubleshooting. So our orchestrator makes this XML API call to the VM series instance, and it hits commit as well. And now we have HA between these two instances. So if our first instance goes down, this floating ENI and associated elastic IP jumps down to the other VM series instance, and no one's the wiser. Everything keeps functioning just fine. So now we have a system completely ready. Go ahead.
Just curious, from a resiliency and HA point of view, HA will take a long time. Is that was okay? Is that the idea? Rather than using elastic load balance instead?
Sure. So the question was, with HA failover, sometimes it can take a little bit of time. And was that okay for this scenario? And could we have used a load balancer to do this? If you're using the VM series firewall for network HTTP traffic and that sort of thing, you can put it in load balancing and auto-scale it across multiple AZs, and everything works great. But for doing VPN connections, you need to have it not go through a load balancer. So that's why we ended up opting for this solution where we leveraged the VM series firewall automation that they already built into the instance for doing that failover for us.
The connection to the on-premises Palo Alto, was that automated as well?
It can be. In the scenario that we built this, we actually had this system set up and listening for a specified VPN connection. And it was mostly because Gigamon was just kind of starting to dip their toes into automation and wasn't ready for us to make API calls to the production system at their office, right? They don't want to see us bring that down and make a bunch of people unhappy. So that was pre-configured for this specific deployment. But you didn't need to configure this with IP addresses specifically, and devil's in the details. I'm not sure it's too important. So the orchestrator is ready for a developer to come in and say, I want a VPC. So we boiled down all of the automation to the point where we said, OK, we need to know who they are, and we need to know what environment they plan on working in so that we can tag resources properly. But we didn't want to make their developers have to answer a ton of questions. So all we say is, OK, you want another VPC? We don't want to ask a bunch of, like, what CIDR blocks do you want to use? So we wrote automation to say, this is the next available CIDR block. Just use that. And so Gigamon IT gave us a pool. They said, all of these can be deployed into AWS. You manage them. So we write automation to grab the next available CIDR block for a VPC. Our orchestrator calls out to the deployment engine, says provision. Once the VPC is provisioned, it comes up with its VPN gateway, and we make API calls to the Palo Alto VM series firewall to make that VPN connection come up. So every time we deploy the VPC, API calls get made by the orchestrator to provision it and make sure that everything's working. Go ahead.
Sorry, how did you calculate the CIDR block? You pre-established, or you calculated every time the developer requests?
So what we did is we had a /16 that we were allowed to use, and we knew that we were going to use /24s every time for each VPC. And so we just stored a table that had all of the available IP addresses. The question was, how did we know which CIDR block we could use? So we just relied on that set of knowledge when we first built the system. And so that's something that you could pre-configure to use a totally different CIDR block range and make that work. The beauty about having all this automated is a developer just got a VPC, it VPN connected to the VM series firewall, and now in our on-premise network, 5-10 minutes later, max, the developer has access to this subnet in their VPC. And they're ready to start testing out. They can use now their automation code. They can go into the AWS GUI. They have IAM permissions to that VPC where they can launch instances now. And they're off to the races. They're happy. And we would also want to automate the destruction of that as well. So they can go in and say, I'm done with it, destroy it. Now it makes this VPC go away, destroys the VPN connection, and makes that subnet available for reuse.
How many VPCs does this scale to?
So due to a limitation of the VPN gateway, the question was, how many does this scale to? How many developers VPCs can we support? due to the limitations of the VPN gateway, the tunnel IP address is auto-generated by AWS. They just say, here it is, you can go. With a retry strategy to make up for when an issue comes up, we can get about 20 to 30, and then we would redeploy these instances in the same VPC again with a new connection back to the office. And so we would just have another set that would come up and be ready to serve if we run out of availability. We'd say, do it again. And that's the beauty of automation with why we built this system with the IP addresses the way we did. We can just do it all again and be ready on our orchestrator to run the next set of jobs and use the new Palo Alto servers.
Routing table-wise, getting traffic to and from, did you just, like on the on-prem, you already knew the IP address there, you just static it?
So the question was, how did we manage routing tables for getting the connections up and working? So what we did is in the control VPC, we said everything that is 300/ go through the VM series firewall. Because it was on-prem, we already knew it's there. That's what it's always going to be. And then in the developer VPCs, well, we know that range that we're using. So in the control VPC, we went ahead and said, you also have access to this. Everything goes through the VM series firewall. And we also, at deploy time, knew what this CIDR block was. But that gets advertised to this side and this side. So Gigamon was the ones that gave us the IP address and subnet CIDRs that it was going to use for the on-prem, for this side. So they went ahead and built it in there manually. And on the development VPCs, we had a choice to make. We could either set it up so we only wanted private connections to go through this system, in which case we would have made it so only the 10x would, 10/8 we could have just done, would go in the routing tables for this VPC. And that means that the on-prem would go through it, the control VPC would go through the VPN connection. But we wanted even more security out of that. We didn't want public internet connections being made all over the place. We wanted to have it cohesive and use the power of the VM series firewall to manage what is allowed to get out. So we actually did 0/0/0 rides the VPN gateway and goes through the VM series firewall, which means we didn't even have any public subnets in the development VPCs. They weren't able to create public ELBs. They weren't able to create elastic IPs and attach them to their system and expect it to work. So everything that they did rode the VPN connection. Right, so all zeros went through for the development VPCs, went through the Palo Altos. Yep. And actually in the control VPC as well, we used the natting functionality of the VM series firewall to nat out the control VPC traffic to the internet. So we have one development VPC up. That's fantastic. But what we really want to be able to do is give each Gigamon engineer a VPC when they want it. So we just went ahead and said, OK, start using it. And developers came in, and they deployed more and more VPCs with the click of a button. Also, as I mentioned, they could just come in and destroy them. So the automation supported being able to knock this guy off, destroy that VPN connection, and then reuse that CIDR block, subnet CIDR block. The other really cool thing about this solution is it could be extended into different regions. There's no reason why any of this has to all be confined to one AWS region. So we could extend the system to actually support US East if the engineers wanted to test maybe a new product that's coming out in Amazon's US East region or something like that, and extend it to all the other different regions. So that is the core of what we built. Does anyone have any more questions before I move on a little bit? Sure.
How did you keep all the VPCs under control, to prevent your cost issue?
Great question. So VPCs don't actually have a cost by themselves. The question was, how did we keep cost under control and organization under control? So the VPCs don't have a cost themselves. The thing that does cost money for this solution for each development VPC is the VPN gateway. I think it's about $30 a month, but don't quote me on it. Go check Amazon's documentation. So compared to what Gigamon had their engineers doing before, where they could launch 3,000 instances as a test because their system can scale to that size, and then they not get deleted, that was more costly than implementing something like this. So it was almost a no-brainer to let them work in this environment and limit their IAM resources on what they can and can't do.
What's the max number of VPCs you've seen, and what's the average number of VPCs that are up and running?
Mm-hmm. So normally, we are kind of getting some of the QA in there as well. Like I said, we're seeing 20 to 30 per cluster at one time. The real question is are they going and destroying their VPC or not? Most of the time, no. And so especially once you've launched resources into that VPC, you kind of want to just see it sit around. So it's continued to grow over time. It's also one of those things where once an engineer gets comfortable with their CIDR range, they kind of enjoy just sticking with their CIDR range and reusing it. But another handy thing that could be added into this system is a cleanup functionality to go in and clean up anything that's in the VPC as a hard nuke option. It says, you know what, I'm done with this. I know there could be things in here. Let's just nuke all of it out so I can get started again with a clean VPC.
Would you monitor this, say, with a Lambda, and then once it reaches a certain threshold, stamp out another one?
What we would do is use our orchestrator to actually do that. So the orchestrator tries to do that, that retry strategy on the limiting of VPN gateways, and it will try and redeploy. And after a certain point, we would say, OK, no, you need to just do a new cluster, a VM series cluster. The really cool thing that we could do with this system as well is we could install a VM series firewall in each of these VPCs as well and get around this whole problem. Because we could manage what the tunnel IP address is, and now the system would scale up to an insane number of systems if we choose the appropriate CIDR blocks and whatnot. The problem with that is each one of these clusters is only going to be able to handle so much traffic due to instance sizes. I'm also a big fan of smaller and more. So having these guys be a little bit smaller and more of them is a little bit nicer to me when I'm working in the automation side of things.
How would this look in a direct connect type scenario? If you're not doing a VPN over the internet, if you were coming across a direct connect, would this have the same structure, or would it look different?
So the issue with doing we call this a transit VPC, is what we refer to this as. And what it is this system manages a connection back to somewhere and then does mesh for everything else, like everything come up and get working. AWS has a limitation on the connections from a direct connect or a VPN gateway or a VPC peer where you can't double hop. Right? You can't do a jump and then another jump. So I would have to look into the details specifically on Direct Connect, but one option that you could do is you could just add each one of these VPCs into your Direct Connect and say, just jump in. But that causes another issue where we have all the internet traffic just going out, either through the office or going straight out to the internet from the VPCs. So what you could do is you could use Direct Connect and say everything connects over Direct Connect to get back to the office. We VPC peer everything here and run our VM series firewalls in a control VPC and say everything go out that way through the VPC peer.
Hey, Dexter, we've got about 5 minutes.
Okay. So the other aspect of all of this was now we're monitoring traffic. We need to also monitor what's happening in AWS. So we have our system we call an accelerator because it makes things a lot faster and easier for someone like me to work in AWS. So we call it REAN Radar, and what it does is it actually can read AWS APIs and give you quick dashboards that tell you how you're doing. It's kind of hard to see here, but right here, the biggest security group in this particular environment, there's a lot of 0, this is a heat map, right? So there's a lot of 0/0 open. There's a lot of good reasons for that. In Gigamon's environment for security groups, that might not be so good. So we would want to drill down into that, look at what security groups are there. And it could also give us a count of how many resources we're using. If we know that we have AWS limits on numbers of different things, we could easily see how we're doing. Are we about to butt up against that limit? Additionally, AWS has the CISO score card that they publish. Scores that they publish. And they say these are the best practices in AWS for maintaining a secure environment. And so we boiled that down to API calls. We said, okay, we need to always have IAMs that don't allow full access. Well, we can do a describe on IAM users and see, does anybody have full access? Well, that's breaking one of AWS's CISO scores. So we count that against ourselves. And this is really CTO friendly, if you will, because now they can go and say, are my AWS guys building things that are compliant, or are they not? And gives them that strong yes or no.
Looks like the whole environment has been built across one single AWS account, right?
Mm-hmm.
Does Gigamon consider spreading to different accounts in order to have easier billing or so on?
So for the system here, there's no reason why you couldn't also do different AWS accounts. And what you'd do is you'd build into your orchestrator an assume role to a different account and say that instance is allowed to do an IAM assume role to get over to this other account and provision over there. Think about this as, this is just VPN traffic, so it can come from anywhere and function just fine. So the question was, do we maintain IAM policies? And the answer is absolutely yes. So Gigamon was already using Okta for doing single sign-on with a lot of their different resources. We actually built Okta authentication into Jenkins. So a Gigamon engineer could go sign into Okta, click the orchestrator button, go in, say, I want a VPC, without even having to log specifically into Jenkins. And then we could tie the Okta username into tags on the VPCs and subsequent resources that they would launch through the orchestrator and say, you can only do things to these instances. Palo Alto VM Series Firewall also has a method for managing some of that kind of stuff of network traffic flow, where you could say, this engineer in the on-prem is only allowed to send traffic to their VPC. It wasn't something that we needed because of the segregation policies were OK for everyone to get around, but it's another really cool thing that you could implement if you didn't want people to just be able to get anywhere in the environment.
So you mean using user ID?
Yes, yeah. So put the tags on the system, and then it would see, oh, its IP address is this, and you can get there, that kind of thing. Any other questions?
Yeah, just out of curiosity, I know you're very orange up there. Do you have any blue, as in Azure? Do you do any Azure stuff?
Yes, we do, yeah.
Is there a REAN Cloud for Azure?
Yes, so we do professional consulting and professional services for any cloud provider that you want to do. We fancy ourselves as being cloud experts in general. AWS is what we work with the most, as 70% of the market share is in AWS, as you can imagine. So, but we are more than happy to help anyone out with any of their cloud needs.
Those specific products, or are they products?
The REAN deploy can work in VMware, Azure, AWS, Google Cloud, I think there might be one more, Rackspace maybe. So yeah, it can support a lot of different platforms, and we use it for that all the time. Yeah. And that was about the REAN deploy, the visibility system, where you can see what infrastructure you're launching.
In your model, have there been a lot of like large data transfers, file transfers, and if so, have you been pleased with the performance and stability of the VPN tunnels with Palo?
Yes. So the question was, have we done big file transfers and had a lot of traffic go through the system, and are we pleased with the performance of it? Because Gigamon's system is about capturing full packet capture on all these systems, one of the things that they have to do is send, truckload of data go through the system. Performance is directly tied to the instance size of the Palo Alto VM series that we launch. So we launch them at an appropriate size, and we can monitor them and see how the throughput's going. But it seems like the VPNs are very stable and manage just fine. One of the nice things that we have a VM series firewall going to a VM series firewall. So it's all Palo Alto's world. Everything works nice and easy. I think we're probably out of time. All right, we'll do one more real quick. Go ahead.
The internet traffic inside from the development VPCs goes through the Palo Alto to go to the internet, or directly from the VPC?
We did from the VPC to internet for the developer VPC goes through the VPN connection and out the internet gateway here to get out to the internet. So they work as NATs for it, if you will. On-prem went straight out to the internet. They only used the VPN for getting up to these private resources. All right, well, thank you guys very much. We really appreciate all the questions you had. So Phil and I will be just outside if you have a couple more questions for us, and then a little bit later we'll be hanging out by the Gigamon booth if you have even more. Thank you.